All right, good morning, everybody. Hope you guys, I don't know if it's morning, I guess it's more afternoon, but good afternoon, good morning, whatever it is to you. Some of you may have just woken up. Hey, so good to be with you guys again after a good spring break. Hope you guys are doing extremely well. Hope you had a good break and kind of back getting into this craziness of online teaching, learning. If you can, real quick, just give me a thumbs up. I should have done this about like 20 seconds ago. Give me a thumbs up or something in the chat box if you can hear me and see me. If you can hear me and see me, give me something in the chat box. All right, Tara's saying I'm good. I assume everyone else can hear me. There we go. Maddie, Scott, Molly, Jake, Jacob, Vandy, Taylor, Kinsey. Cool. All right, so let's start. Going to start just a little bit different. Cool. Thank you guys for being here. I know some people are in chemistry right now, and they said they may be a little bit late, so that's completely fine. If you ever have like a Miss Ray class over my class or something like that, by all means, go to that class. Some people want it like where your classes are at normal times, but I think this is a different time, so it calls for different kind of measures. So I find it more convenient to do it the way I am, but I'm always recording it. It's always on YouTube, so feel free to always go back and watch if you have chemistry. I don't know if there's any other classes like jumping into the live stream or whatever. So real quick, I hope you guys had a good spring break, okay? I don't know what your spring break was like. I don't know if anybody went anywhere crazy or did anything crazy. We went to the park. We went to our backyard. We went to places like that. That's about as much as we did. Not sure if anybody went anywhere crazy or if you can go anywhere crazy. But it was a great week of rest for us. I've been on the grind, doing these videos, preparing for these videos, doing all that type stuff for the past 3 weeks. So it was a good break for me and my family. So again, hope you had a good spring break. I miss you guys. It's not the same being in the classroom. No, I'm here for you if you need anything. Next thing, turning stuff in. If you remember from my email, I told you had two options. You had option 1 and option 2. Option 1 and 2. Option 1 is what I have listed right here below in the picture. I just wanted to bring that up to kind of bring it to your attention. Everything is due to me. Everything is due to me Friday by 4. Okay, whether that's an online submission via PDF, or if it's taking it to the school, dropping it off here, and picking up your new packet here. Okay, whatever you would like to do, but this is due Friday at 4. Okay, 4 o'clock p.m. I'm going to go there Friday. I went there yesterday, and I saw several people had already turned theirs in, so thank you so much. I don't want to name names of people I saw, but I know I saw Catherine. I know I saw Adam Orell's in there. But I have gotten some online submissions. Maddie, Scott, I got your online submission. Jake, I got your online submission. So I am receiving those. I'm going to put those in the grade book on Friday. Okay, so Friday at 4, I'm going to go pick those up, and I'm going to punch everything into the grade book there. All those homeworks in that study guide, and I appreciate you guys getting them turned in. So again, just wanted to review with you the two options. Option 1, you go to the school, okay? And right here, this is like the front office, like the elementary office. Right back here is the athletic office. My wife's room is just right down here. There's a table. You can turn your old packet here. And as I said in the email, the convenient thing about this one is that you can pick up a new packet. I know some of you guys don't have printers. Hey, I didn't have a printer. I don't even have a printer now. So in my house, it's kind of just obsolete. Everything's electronic. But in a moment like this, that's why I'm making this option available for you. Stop by there, get it. Make sure we take this serious. Don't be hanging out. Don't be like making it, hey, I'm going to the school at 10 o'clock in the morning. Want we meet there and hang out? That's not an option, guys, because then they'll cut this stuff out, so I won't be able to do it. And then you'll have to send me everything, and that can be a chaotic mess. Okay? So, within that, looking at this right here, okay, make sure that's option 1. Or option 2, I told you could send it to me by PDF. Everyone that sent it to me has sent it to me by PDF. I attached the YouTube link into the message of how to do that with your iPhone. You actually don't even have to have an app. You can do it directly from your iPhone. If you're an Android user, I'm sure they have something too. Just YouTube it, and I'm sure that can help you there. Any questions about turning stuff in? If you're good, give me a thumbs up. If you have a question, ask a question in the chat box now. Cool, Tara. Yeah, and I'm sure you don't have to tell me you turn. I'll for sure get them all. Any questions? Everybody good on turning stuff in? I assume we're good. All right. Continuing down the agenda. Hey, okay. Great question. Is this, who is this? Is that you, Victor? Yeah, okay, cool, Victor. Hey, so Victor, if you haven't picked it up, we're going to continue with the notes today. Maybe just get a sheet of paper and work through the problems like we're going to work through the problems. That's completely fine. Or I don't know if you have like an iPad or something. Something you could do if you have like the app here. Mine's going to look maybe a little bit different than yours. Here's the teacher's app. Everything, guys, is on Canvas. If you go to your course is Algebra 2. So if you go to that course there for you guys, make sure you guys can see this. And under the word files is everything you need for this class, okay? Under the word files right here is everything you need, okay? So if you need something, it's going to be under files. So hit files, and then we're on chapter 5 now, okay? So chapter 5, and then look, this is everything. That's everything there, okay? So the notes for today, so you just click on lesson 5.1 notes / homework, and it's over here to your right, okay? You can print that off if you have a printer at home, or some people know how to like download that and then able to write on it, okay? We're all different tech savvy. I don't want to spend time like going into that, but you can kind of do some stuff within that if you wanted to take it out, but that's there, okay? Something else I wanted to show you guys within this, and I know this is a little bit blurry just because it's a screen, but you're kind of getting the general idea, is if you need, like, go back to your files. If you look at chapter 4, I load everything in there. I load everything in there that's completed. So, like, notice 4.5 notes completed. Okay? If you just click that, that is my notes right there completed. I didn't probably do as good of a job last chapter in loading those up as quick as I should have, but this time I will. As soon as I get done with these notes, I'll take a picture and I'll upload it there so you can have the finished notes, even if you come in late and you want to see like something else, okay? Or you can always go back, watch the video, and pause it from there. But here you see those are our finished notes from chapter 4.5, okay? You guys did extremely well on your test. I'm sure there was some questionable things happening, but it is what it is at this point. So I try to make it where you had to take it on your own, but some pretty good scores across the board, okay? That is that. I hope that answers your question, Vic. Going back to kind of our notes agenda today, something else that we want to pay attention to. So I'm just going to make you guys have class every Monday and Wednesday at 12:30 p.m. Every Monday and Wednesday from here on out until we come back to school. It's going to be Monday and Wednesdays at 12:30. You will not have any class on Friday. Okay, so every Monday and Wednesday at 12:30, and we'll just keep it like that. If you're cool with that, give me a thumbs up. I think most people should be pretty good with that. Give me a thumbs up if that works for you. If it doesn't, give me a thumbs down, I guess. I don't know. Hey, actually, Vandy and Vic, this is actually, I actually did this on purpose because I figured that some of you would not be able to get the packet within the day. Lesson 5.1 notes, this is for Vandy and Vic and some of you guys who don't have the notes yet, they came with the last packet. Am I correct on that? Can someone tell me that? Didn't 5.1 and 5.2 come with the last packet that you got in April, or excuse me, March after junior retreat? Can someone say yes, that's correct, or no, that's not? I don't know if you still have that packet or what, but okay, cool. Andrew said yes. Okay, yeah, cool. Yeah, all right, so it came with that packet because I knew there would probably be some overlap there. So just try to get that new packet by the end of this week. But this should be in the old packet. Okay, cool. Thank you, guys. All right. So that is that. We're going to be Mondays and Wednesdays at 12:30 from here on out, guys. And next thing, make sure you are staying up to speed with everything. I think it's easy for some of you to submit all this work to me because you've kept up with it the whole time. Those of you who have not kept up with it, you're like scrambling now. You're saying, hey, can you send me this? Can you send me that to other people? I promise you guys, just keep up with it. I'm not asking you too much, I don't think. We're doing less work now than what we would do in class. So do the notes, do the homework the next day or so, and then especially with us not having class on Friday now, this should be a little bit more manageable for you. So make sure you're staying up to speed. Something else I want to talk about, you guys, I actually do. I know this is going to sound probably a little bit ironic coming from me, but I actually do miss seeing you guys. And with YouTube, there's a reason I use YouTube. I don't want to go into the difference of YouTube and Zoom, but there is a reason I use YouTube. So, but I understand Zoom's pretty cool because you do get to see other people. What are your guys' thoughts? I don't want thumbs up or smiley faces here. I want just your thoughts. Maybe type it in the chat box. What if we did a Zoom maybe every other Friday? So like not this Friday, but do a Zoom next Friday. Meet at like 12:30 and just simply talk. No math. Just maybe ask some questions, see how everyone's doing, get to see everybody's faces, maybe for like 15, 20 minutes. Thoughts on that? Is y'all think, hey, yeah, that sounds good to me? Or like, hey, that sounds like the dumbest thing in the world, Mr. iPod. We love you, you're cool, but that's dumb. Just let me know. Okay, Tara's cool with it. Taylor's cool with it. Molly's cool with it. Cool. And we can do a question and answer where you could ask me different questions about different things. Again, with us being in this type setting, and I may be able to drop some stories or something like that, some crazy stories that I've encountered through my years of life. We can make it a little bit fun. Okay. Not seeing no negative. Again, this. No, Jake, come on now. Do you know anything I do is obnoxious? We'll keep it under control the best I think we could. But to my knowledge, I can mute everyone's mic, correct? I mean, that's my knowledge of Zoom. Okay. I assume I can mute everyone's mic as the host. I haven't done too much of that, so we'll kind of check that out. It won't be mandatory or anything. You don't have to come with it, but if you want to see everybody, you want to see me, kind of talk to me in a different setting than like right here, then you should be good. That should be kind of fun. I'll send out an email next week, and I'll just include it in our schedule for that Zoom on Friday. Next thing, email me with any questions you guys have. If you have a question, email me the question. Okay? Simple as that. If you have a question, shoot me an email. There's no reason any student of mine should be going around saying, I don't have a clue what to be doing in Mr. iPod's class. Okay? If you have a question, email me the question. All right? With that, let's go ahead and jump into lesson 5.1. Now we're at chapter 5. And chapter 5, and I don't have a single pen on me, so let me grab some pens. While you're getting that out, I'll grab some pens, have that ready to roll. Okay, give me a thumbs up if we're ready to start with lesson 5.1. Cool, cool. All right, so just to get going a little bit here, chapter 5 is over rational functions and rational exponents. Okay, so chapter 5 is all about rational functions and rational exponents. Now, with rational functions and rational exponents, the key rational is ratio. Okay, and ratio is short for fraction. So what we're dealing with here, last chapter 4 we dealt with rational functions. So like f of x is equal to x plus 1 over 2. We dealt with those, and that's a horrible color for this. F of x is equal to x plus 1 over 2. So we dealt with functions like that, and we learned all about vertical asymptotes, horizontal asymptotes. We learned about holes. We learned all about that. But now we're going to go to rational exponents in functions. Okay? So when we have a exponent, that is a fraction. Now, let's start easy, okay? Let's start with what a exponent is, okay? So going back to this, you know that 7 squared, okay, is equal to 7 times 7. 7 times 7 is 49. That's pretty simple. But that's not a rational exponent. That's just, we know that's just a simple integer. An integer exponent would be like that, 2, 7 squared. Same thing with 8 squared. We know that 8 squared is 8 times 8, which is 64. All right. And then we also know that 9 squared is 9 times 9, which is 81. We know that 2 cubed, we know that the exponent tells us how many times to multiply the base by itself. So it's simply just this, 2 times 2 times 2. So 2 times 2 is 4 times 2 is 8. So 2 cubed is 8. Again, just a little refresher on exponents. Now number 5 and number 6 are kind of tricky. Kids always forget this, but this should be pretty simple. What is 8 to the 0th power? Someone type it into the chat box. No problem, Chris. Someone type that into the chat box. What is 8 to the 0 power? I will tell you this. It is not 0, so backspace that 0 if you put 0. Very good, Molly. It is 1. Anything to the 0 power is equal to 1. And 123 to the 0 power is equal to 1. I tried to stop you, Tara. I tried to stop you before you typed it in. No worries, though. You're fine. All right. Then jumping down here to number 7. Now, when I taught this in my honors, the honors algebra 2 class, they had never seen negative exponents before. I thought they probably would have, but they did not. So with negative exponents, okay, there is a couple steps you need to follow, probably 2 steps you need to follow, and that will get you the answer every single time. So looking at 3 to the negative 2, we no longer can say, we can't say that this is negative 9. That's not the way that works. So we can't really necessarily look at it as the exponent tells you how many times to multiply the base by itself. Okay, so that works with integer exponents, but not 0 and not negative. And I guess not integer, but whole numbers, because these are integers. So 3 to the negative 2. Yeah, very good, Tara. So here's what we're going to do. We're going to kick the negative out. So I always say kick it out. First step, kick the negative out. Kick the negative out. And then whatever you have left, what do I have left? I have 3 squared left, right? If I kick that negative out, what do I have left? 3 squared. Whatever you have left, put it under 1. Whatever you have left, put it under 1. So I have 3 squared left, so I'm going to say 1 over 3 squared. And then I clean this up right here. 3 squared is 9, so that's 1 over 9. So again, anytime you have a negative, kick the negative out. Whatever you have left, put it under 1, and then simplify this right here to, which would be 9 there. Now, just to show the backing of the calculator with this, my calculator battery is a little low. Should be okay. Just to show some backing to this, if I say 3 raised to the negative 2 power, and I hit enter, I get that, and that is, if I change that to a fraction, that is 1/9, which is what I got right there. Okay? So just some calculator backing of why that works and the proof behind that. Okay? Then from there, we jump over here to number 8. So number 8, it's a negative exponent. Kick the negative out, and whatever you have left, put it under 1. 1 over, what's left once you take the negative out? 5 cubed. So 1 over 5 cubed. Which is equal to 5 cubed is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is like 5 quarters, so that's like 125. 1 over 125. Yeah, very good, Tara. All right, good. Jump down here to 9. Same thing. When you have a negative exponent, kick the kick the negative out. Whatever you have left, which is 4 squared, put it under 1. 1 over 4 squared. And of course, that's equal to 1 over 16. Okay, going to 12 and negative 2. Kick the negative out, and I'm left with 1 over 12 squared, which is equal to 1 over 144. Now, looking at number 11. So that's just a quick review of kind of exponents. You need to know those exponent rules, especially the negative and the zero, to kind of get us going here. So, something about this, okay, that is very unique is, do you all remember at the beginning of the year when, I think this might have been like the third day of school, you came in and you did like 1 squared, 2 squared, 3 squared, 4 squared, and over here was like the square root of 1, the square root of 4, the square root of 9, the square root of 16. Give me a thumbs up if you remember like doing, and I had music playing and you were doing that and you were completing that sheet there. Give me a thumbs up if you remember that. Yeah, okay, cool. Yeah. So you remember that, and like some of you guys were tripping at the beginning saying, my gosh, this guy is absolutely nuts, thinking that, yeah, Andrew, you wouldn't remember this. So everybody was going crazy like, oh my gosh, this guy's an animal, thinking that we know all this stuff already. But if you remember, the key part was that the answer was there already, right? Because the answer to these were right here, right? 1, 4, 9, 16. And the answer to all these were just 1, 2, 3, 4. Okay? Now the reason that is because these two are squaring a number, and this right here are inverse operations. Okay? They are inverse operations. To square an x and to take the square root of an x is inverse operations. So they're very similar in what they are and what they represent. Okay? So this is where we're going to write a little bit of note right here. We're not going to use words. We'll probably just use symbols. Okay? So here is the unique thing. All right? If we have a number like c raised to the m over n, these are just variables to get us to have the idea of what's happening and what's going on. Okay? So if you have something like this, a number raised to a number over a number, this is a rational exponent. This is a rational exponent or a fractional exponent. Rational just means ratio, which is short for fraction. So if you have a rational exponent, okay, you can rewrite this like this, guys. 2 different ways you can rewrite it. You can rewrite it like this, where the denominator becomes what we would call the index of the square root. And then this would look like this, c to the m power. Okay, so rational exponents are basically just square roots. Okay, rational exponents are just square roots. So a number raised to a fraction can be set to equal this. Make the denominator the index. We call this right here the index. Because we know we could have a square root or a cube root, okay? And that determines what you do, you know? So a square root, you ask yourself, the square root of 64 is 8. Because 8 times 8 is 64. But the cube root of 64 is 4. Because 4 times 4 times 4 is 64, okay? So there's a difference in square root and cube root. Now, most of what you see is a square root, and it's just written like this right here. These two are the same. Okay? But the denominator of your fraction becomes your index, and whatever the numerator is, it can be written as a power to the base. This is the base on the inside. Or the other way to write this is like this. The denominator is still the n, so you'd say n c right here, but then you put this in parentheses and put it to the m power. Those are the same thing. All 3 of these are the same thing. And guys, that's the only thing you need to know when it comes to this lesson. You need to know this right here. You know that, you're going to be in great shape. Okay? So your denominator is always going to your index in both of them, but the difference in these two is you can put the m on the inside or you can put it on the outside. Depending on what it is, sometimes you may want to put it on the inside, but sometimes you may want to put it on the outside. Either one of these ways work, but it allows us to solve for a rational exponent. All right, let's get started here. So number 11, 16 raised to the 1/2 power. Okay, so here we go. Here's my C. M is 1, N is 2. And I need to make it look like this. So I'll start. So could, Andrew says, so could the index be something like 5 if it was something to like 1/5? Correct, Andrew. If it was like something to the 1/5 power, the index would be 5. I don't know if you'll see something quite like that here, just because that's a big root. That's a big nth root to go to, but you could see that. All right, very good question. All right, so let's look at number 11. So 11. So watch this. First step, I'm going to make my square root sign. I'll make a list of steps over here. First step, square root sign. Second step, get the index from denominator. So first step, make a symbol. Make the square root symbol. Second step, get the index from the denominator. Just want to add this in. There's 16 of you watching today, and I can't tell you how much I appreciate that you're watching. I know some kids aren't into this. Hey, be an encourager right now and encourage people to, hey, get in class, do your work. Okay, this is not a downtime. This is not a time to sleep. You can fail. You can still fail this. And I know some of you are worried about your grades for the fourth semester, just because they determine eligibility for the fall. Okay, so let people know that. Say, hey, this is not a time to fail. Be in class. Be paying attention. Be turning your work in. Just want to throw that plug in real quick. All right, so get the index from the denominator. So my denominator here is 2, so I'm going to move that right here. Now, we're used to seeing that like this right here. This and this is the same thing, guys. A 2 just means a square root. This means square root. Okay? Most of the time you're taking square roots of stuff, so that's why it's just universally known that there's a 2 there. All right? Then, third step, what you're going to do is put the base in. Put the base in. Okay? So put this base right here, whatever this is, put it right here. So 16. Okay? And then the fourth step, put the numerator in. Now, we have 2 options for our numerator. Okay? I'm going to show you both here, just so you kind of see what we're dealing with. So my first option would be to put my numerator, to put it on the inside with raised to the C power. So like put it there. Or guys, you could do it like this. Same thing, do your square 16, and then you can put it like this and put that to the first power. Either these are the same thing. They're going to produce the same answer in a calculator if you solve it in your head or whatever. These are the same thing, okay? So I ask myself, what is 16 to the first power? Anything to the first power is itself, okay? So that's just really saying what's the square root of 16? And what is the square root of 16? What times itself will give you 16? 4. Okay? Over here, what's the square root of 16? Well, it's 4. 4 to the first power? 4. So it's just a matter of form here, okay? Not a lot of math, definitely not new math you're learning. It's just a new form of how to write a rational exponent. All right, let's jump over to number 12. All right, here we go. First step, draw your symbol. First step, draw my symbol. Second step, put my index in. My index is the denominator. It's 2. Third step is to put the base in. The base is 49. And then the third step is to put the numerator in. So we can put it on the inside, or we can say the root, that base, we can just say it to the first power. Now you may be saying, hey, Mr. Alpha, this whole one stuff's pretty simple. We know what it is. Again, we're just trying to establish the routine because as you can see in these next problems, it won't be 1, so it could be a little bit more challenging. Okay, so here we go. 49 to the first power is just 49. So the square root of 49, we know that to be 7. Okay. And then the square root of 49 would be 7. And 7 to the first power is 7. Okay. Again, everything's going to be about this form. If you can know this form, this lesson will be easy for you. Okay. Knowing the 2 different ways you can write these. All right, give me a thumbs up in the chat box if you're kind of seeing this a little bit. You're kind of flowing with it. Give me a thumbs up. Just I want to make sure you're still there. Cool, Chris. Good, Tara. Good, Kenny. Good, Adam. Good, Andy. Now, coming back to this over here, you may be saying, well, hey, I'm not really seeing how that really connects with what you're talking about now. Okay? Well, think about 2 squared. Let's just take this one. Let's say 2 squared is equal to 4, and the square root of 4 is equal to 2. We know that, okay? Okay, so, but the difference is here, guys, is that this right here is not a rational exponent. Can I make it a rational exponent? Yes, I can make anything a fraction. I just have to simply say 2 raised to the 2 over 1 power. Okay? Now, you don't have to write this down. I'm just trying to show you the way exponents and square roots just kind of flow together. Okay? So right here, I draw my sign. I do the index of the denominator, which is 1, and then I say 2, and I have 2 options to put the numerator. I can put it in here or on the outside. Either one works. Now, here's the thing, guys. There is no such thing as a root to the first power. Like, there's no such thing as the first root of something. So that right there, because square roots start with 2, okay? Because we're not saying what times itself will multiply what times it. See, it doesn't even make sense. You can't even put it in words what it means. So that's not there. And 2 squared, then we're just left with 2 squared, and that is equal to 4. So that's our process of how we're working, how we work from exponents to square roots. Same way over here, guys. Think about this. Now, this is going the opposite way, okay? But think about this. This saying the square root of 4 is 2. So that would look like this. There's a 2 there, and we know that we could put a 1 there. So that would take that to 4 to the 1/2 power, which is equal to 2. I got the denominator. from the index, I got the numerator from this right here. Since it'd be 1 since nothing else is impacting it. And then as we know, of course, that would take us back to this, the square root of 4 to the first power. We know that would be 2. 2 to the first power is 2. So I'm just trying to show you how you can go from exponential form to radical form. Exponential, radical. Radical to exponential. Okay? They both work. You can go back and forth either way. All right. Jumping back over here to 13. Number 13, 16 raised to the 3/2 power. Our very first step, do the square root. Okay? Square root sign. Next step, yeah, you could say that. Hey, you're cool, Ivan. Thanks for being here. Yeah, very good, Vic. You could say that something to the 1/2 power is the square root of the base. You'll see some tricks along the way. All right, so let's look at this. 16 to the 3/2 power. So your index is 2. My base is 16. Now watch this. We're going to say 16 cubed on the inside, or we could write it like this. The square root of 16 cubed. Now, if this is 1, if that's option 1, and that's option 2, okay? Type in the chat box which one you think would be better to go for here, okay? Type in the chat box, what would you go with here? Go with 1, option 1, or go with option 2? What do you guys think? Tara says 1, okay? Chris says 1. Come on, let me see some answers. Kenny likes 1. Anybody else? Okay, so I got 3 of you to say something. Okay, cool. Taylor says I use 1, but I think 2 would be more helpful here. And Taylor is exactly right. Very good, Taylor. Your best option is to go with option 2 here. Now, you're saying, well, you know, if I have a calculator, what difference does it make? And you may have some merit within that. But for me, I think it's easier to go with option 2 here. Now, watch this and watch why. Because what is the square root of 16? Square root of 16 is 4. And then 4 cubed. 4 times 4 is 16. Times 4 would be 64. 1 second, Vic. Okay? Or over here, you'd have to say the square root. And this is where I think they separate themselves. I don't know what 16 times 16 times 16 is. I know what 16 times 16 is. 16 times 16 is 256. But I don't know what 256 times 16 is, so I would have to use a calculator here and say 16 raised to the 3rd power. 16 raised to the 3rd power. 4,096. Now, I definitely don't know what the square root of 4,096 is. I actually do now because I know the answer over there is the same. But I'd have to say the square root of 4,096, and that would take me to 64. So we get the same answer, guys. Get the same answer. But I just see option 2 as so much easier here. Okay? I don't know if you would agree with me that or disagree with that or what. So Vic, you said, isn't it multiplying the base with the root? Not multiplying, I wouldn't call it multiplying the base with the root. But a way you can look at it is just the square root of this raised to that power. Now, Vic, I know you're someone who likes to do a lot of mental math, so that's the way I would look at it if I was you. Look at it as this: the square root is 16 cubed, and you could probably do that in your head fairly fast. All right, very good. Let's jump over here to number 14. All right, follow our steps, guys. Follow our steps right here. What we have, first step, square root sign. Now let's get the index. Our index is always our denominator, 2. Okay? Write down our base is third step. Put our base in. Fourth step is to go inside here and to put 3 here. Okay? Or I could write like this, the square root of 4 cubed. Now, let's take another poll. Are you team 1 or team 2? Which one are you taking? Are you number 1 or number 2 here? Which one do you like? Which one are you going with? Type it in the chat box, please. Hey, we're kind of mixed. Some people like 1, some people like 2. I'm not a hater of the way you do math as long as you're doing math. So, totally up to you here what you're doing. I'll work it both ways right here. So, the square root, 4 cubed is 64. Okay, it's 64, and the square root of 64 is 8. The square root of 4 is 2, and 2 cubed, 2 times 2 is 4 times 2 is 8. Same answers. We're just going about a couple different ways. Hey, you guys know me. That's right, Chris. The tables have turned. So some people are still on team 1. I'm cool with that. Again, my goal is that you're getting the right answer and you're understanding why it's the correct answer. Okay? All right, let's jump down here to number 15. 15 is 81 raised to the negative 3/2 power. Okay? 15 is 81 raised to the negative 3/2 power. Yeah, you're cool, Terry. You know me. I'm not a hater. I don't hate. All right. Now, the key here is this. It is to the negative power. So, with our negative, when we have a negative, any negative exponent, you got to get rid of the negative. So, our first step here is to kick the negative out, and we rewrite everything we have left under 1. Okay? So, it should look like this. 1 over 81 to the 3/2 power. Yeah, Vic, that's correct. Okay. So 1 over 81 raised to the 3/2 power. Now we have to simplify this right here. Okay. So I'm going to write that as 1 over. Now right here, we're going to write we write our square root sign or our root sign. Not test. Here's going to be a square root. Move our denominator, whatever our denominator is, put it here. Put our base in. Now, this is where we may begin separating ourselves a little bit. Some of you can put a 3 in there, but I'm not, okay? I'm going to make up my parentheses, and I'm going to go the second option and put the 3 on the outside. That's total preference there, whatever you like. I try to avoid the calculator at all costs, and I know no one in this class knows off the top of the head 81 cubed. Okay, so that equals 1 over the square root of 81 is 9. And then we got 9 cubed. I want to say 9 cubed is actually 729 off the top of my head. I don't know though. 9 times 9 times 9 times 9. Not too bad. Not too shabby, Mr. iPod. 729. So this right here is, so our final answer would be 1 over 729. Okay, looking at 16. 16. 64 to the negative 4/3. When you have a negative exponent, first step is to kick that negative out. Okay, so let's kick the negative out, and I have 1 over 64 to the 4/3 power. From there, we put this in radical form. We call that radical form. So 1 over radical, the index is 3 this time. My base is 64. And guys, I'm not going to raise 64 to the 4th power, so I'm going to put that on the outside. Okay? Then we ask ourselves, what multiplied times itself 3 times will give me 64? And that may be a little bit challenging, but that should be 4. Okay, 4 times 4 times 4 is 64, so 1 over 4 to the 4th power. And I want to say that is 4 raised to the 4th is 256. Yeah, that's right, 256. 4 to the 4th power is 256. All right, moving on. Jumping down here to number 17. First step, kick my negative out. Whatever I've left, put it under 1. Okay, and then let's write this in radical form. So it should be 1 over, write my radical, write my index, write the base, and I'm going to find it easier to put that on the outside. From there, I simply say that's 1 over the square root of 36 is 6. 6 cubed. And I want to say that's 216. I'm not 100% sure. Yeah, that's correct. 216. Hey, do number 18 on your own. Type your answer into the chat box. So once you get it, type your answer into the chat box. Even if someone's already answered it, type that in, go ahead and type your answer in there as well. Okay? Work number 18, type your answer into the chat box. All right, cool. Seeing some answers come in. Very good. All right, so first step you should have done was kick the negative out. Write it over 1 over 64 to the 3 halves power. And then take that to 1 over the square root of 64 cubed. That would be 1 over 8 cubed, which is 1 over 512. Very good, guys. All the way around. Okay? Very good. Any questions on anything on the front page? Give me a thumbs up if you're good to go to the next page. Give me a thumbs up. I want to make sure you're all still here with me. All right, cool beans. Jumping to the back side, okay? Jumping over here to the back side. Looking, it says write each expression in exponential form, okay? So write each expression in exponential form. So this is just practice for you to go between the different forms, okay? This will be good for you. All right, so this first one, 19. The square root of 3x. Okay, now it wants it in exponential form. That means it wants an exponent. Okay, in this case, it's going to be a it's going to be a rational exponent or a fraction exponent. All right, so it should look like this. We know that there's a 2 there. If there's nothing there, there's a 2. There's no such thing as a 1 root. Okay, and if there's nothing here, that should make that a 1 there. Okay, so then that should look like this. 3x is my base to the 1/2 power. 3x raised to the 1/2 power. And something that we need to specify here, guys, something that I need to specify here to make sure we get this right is we want to make sure we put this 3x in parentheses. Because it's not the x raised to the 1/2 power, but it's the whole 3x raised to the 1/2 power. So I have to put the 3x in parentheses and raise it to the 1/2 power. All right, jumping over here. And again, think about your base. Your base is 2 right there. Okay, and it's this whole thing. So the way I need to write this would drop your base. I would just write your base down, whatever it is, put it in parentheses, and then put your fraction in. This is going to be 5 over 2. This is always your denominator. 7m over 5 half. Okay, looking at number 21. Again, follow that step procedure. Just copy this down, 5v to the second. Now, this one looks a little bit confusing because you would think this one right here, the square, would work for all this. But the difference is this is not in parentheses. The 5v is not, so the square is just with the v. Okay? So whatever's under the radical, your first step is to bring it down. Okay? Put it in parentheses. And then now notice here. The 4 is going to be your denominator right here because it's in the index. And this is going to be, think about this, it could be to the first power. So it'd be 5v squared to the 1/4 power. Because there'd be a 1 on the outside here. Now, if this problem looked like this, here's an example, Molly. Don't freak out on me. An example. If this looked like this, the 4th power to the 5v to the 2nd power, then that would be 5v to the 2 over 4. Okay? But it's not like that. It's not 5v squared. It's just v squared, so it has to be written like this right here. that is something totally different. Okay. Look at number 22. Now look at this. So again, whatever's here, write it down. 10p, right, in parentheses, inside. And then this is on the outside. That's my index. So I say 5/6. All right, continuing right on. Write an expression in radical form. Okay, write these expressions in radical form. So again here, looking at this is my index. This is on the outside. So it wants it in radical form. Radical form is a radical is the same thing as kind of like a square root, cube root, same thing. So we call them radicals because it's not just a square root or a cube root. They're just a radical. It's just the radical symbol. So it wants it like that. So again, write your base down, 5k. Do your symbol. Put your denominator in and put it all to the 5th power. Or you could write it like we did in the front, but you got to be specific about it. So you could say the cube root of 5k to the 5th power. If you do that, you have to put the 5k in there. If you do this, that is not right. Okay? Now notice on the front we didn't have that variable there, so that's why we could have done that. Okay? But this will not work. Okay? It has to have the parentheses saying it's going to the whole thing. So either one of these answers are correct. All right, looking at number 24, 2k raised to the 5/4 power. So drop your base, radical sign, denominator comes down, 5's on the outside. Or, of course, you could write it like this, the 4th root of 2k to the 5th power. Either way works. Those are the same thing. All right, jumping down here to number 25. Again, write our base down, 2r squared. Write your radical sign. Write your whatever's here. And then since it's to the 1st power, I don't have to put everything, I don't have to put it in parentheses and put it to the 1st just because it's kind of, it would be known that that's to the whole thing is to the 1st power. All right, moving right along. 26, drop that 10 in down. And then the square root sign. 5 is our denominator, it goes there. And 4 is going to be on the outside. And of course it could be written like the 5th root of the quantity of 10n to the 4th as well. Either way works. That's why I like it on the outside more, because you don't have to remember like to put parentheses or something like that around it. All right, jumping down here to the last thing we're doing today, solving equations with rational exponents. All right, so, or actually give me a thumbs up if you're good 19 through 26. If you're understanding how to go from radical to exponential, give me a thumbs up in the chat box. Let me know you're still here. Good Andy, good Kenny, good Tara, good Taylor. Cool. All right. Very good. I hope this is making sense to you guys. So, going down to solving equations with rational exponents. Looking at this problem right here. What do you all think we should do in order to solve this equation? Someone type what you think into the chat box. What do you think we should do here to solve for n? I want to know what n is. So what do you think we should do? Crickets are in the house. So, what you're going to do, n is the base. Hey, yeah, okay, Taylor. Yeah. So basically, we don't want to work with this. We don't want to work with this rational exponent. So what we're going to do is to change from exponential form to radical form. Okay, so in order to solve equations with rational exponents, you are going to change your problem from exponential form to radical form. Okay, so looking at this, let me kind of dive down here a little bit more. All right, let's look at number 27. All right, if I'm looking at number 27, 4 equals n to the 1/3 power. All right, I want to change that to exponential form. So the 4 is not going to change. It's going to stay 4 is equal to, but I want to change this right here. Give it a second, it'll adjust. I want to change this right here to radical form. Okay, so here's what that would look like in radical form. Drop your bases in. Draw your sign. That right there is your index. And the 1 is just kind of on the inside. But we know since it's 1, we really don't have to put anything there. Okay, don't have to. Okay, now we have 4 equals the cube root of n. All right, so using what, now here's my question. I put 4 here and I changed that to this. I have not done anything to either side of the problem. I just changed this form from n over 1/3 or n raised to the 1/3 power to the cube root of n. They're the same exact thing. So I haven't added, subtracted, multiplied, divided, or done anything yet. So I'm still following the rules of equations, which says what you do to one side, you got to do to the other. So I haven't done anything to this side yet. I just changed its form, and that's completely fine. So now what will I do to both sides in order to eliminate the cube root off the end? What I do from on both sides, I want someone to type that in the chat box. What am I going to do to both sides in order to isolate the variable n? Crickets again. I hope you guys are still with me. Oh yeah, there you go. Thanks, Adam. Cube both sides. So the inverse of a cube root is to cube it. So cube this side and to cube this and this side. Yeah, very good, Tara. Multiplied by an exponent of 3. Very good. Now, the cube root and the cube cancel each other, leaving us with n is equal to whatever 4 cubed is. 4 times 4 is 16 times another 4 would be 64. So n is equal to 64. Now you could use your calculator here and type that in just to kind of make sure that's still true. So you could say 64 raised to, and I'm going to do a fraction here, raised to the 1/3 power. And we can see that that is 4. Okay? So we're still good there within that. So that's just a way you can check your work to make sure you're good. All right. So going on from there, looking at number 28. Okay, same thing here. Follow your step. Change from exponential form to radical form. So if I change this from exponential to radical, it look like this. N, okay, or actually the square root. Do your base, then your radical, then your index, which is the denominator. Then copy your base down. And then this is all to the 5th power. Now, 2 options here, guys. I can put the 5 on the inside, or I can put the 5 on the outside. I would encourage you to probably put the 5 on the inside, but totally up to you. I mean, excuse me, on the outside. I said inside. I would encourage you to put the 5 on the outside. Okay, now this actually presents something a little bit different, okay? Because I can't just cube root everything to get that off because that's to the 5th root there, okay? Or that's raised to the 5th power. So in order for me to get that 5th power off, watch this. In order to get that 5th power off, I'm going to have to raise both sides to the 5th root. Okay? Now watch this. In order to get the cube root off, I had to raise it to the cube. I had to do the opposite. So the opposite of raising something to the 5th power is taking the 5th root of something. This is going to look funky, but hang with me. And then what I do to one side, I have to do to the other. And you may be saying, well, why do you have to do that? Okay? The only way to isolate n is to get that 5 off of there. And the only way to get that 5 off of there is to do the root. Put the index as the same thing as that. Okay? So watch this. The 5 cancels with this 5th root. So I'm left with the cube root of n is equal to, what times itself 5 times will give me 32. So you can use this on your calculator. If you hit the math button right here, which is below alpha, if you hit math, you can see the number 5 right here. If I scroll down to number 5, it's right there. And that will allow you to put a 5 into the index, and then you can say to the 32. And that is 2. Okay, different calculators do different things. So if yours doesn't look quite like that, it should have something where you can type maybe the 5 in first and then it'll have an X or something. I think that's the way older calculators use it. So I now know this is 2. But I'm not finished with this problem yet because n is not isolated. So I have to isolate n. So in order to isolate n, I'm going to have to cube both sides. So you're just going to see this going to go back and forth a lot, okay? So, because the only way, the inverse operation of cube rooting is to cube. What I do to one side, got to do to the other. The cube root and the cube cancel, leaving me as n is equal to 8. Okay, and then I could always go back and check to make sure I'm correct using a calculator. Jumping down to number 29. All right, first step, always change, okay, always change from exponential to radical form. Change from exponential to radical form. So to do that, I'm going to copy my 64 down. And to do that, I write my symbol. I bring my index down. I bring my base. I bring my cube down. Now, I could do this with a cube on the inside or the outside. Whatever you want to do, totally up to you. I find most of the time it's easier to put it on the outside. Okay, now again, notice I need to isolate x here. But the issue is that I have a cube on the outside. So what's the inverse operation of cubing? To cube root. So I have to cube root this side and this side. Now watch this. The cube root and the cube cancel, leaving me the square root of x. And the cube root of 64 is 4. Okay? Then from there, I got to get the square root off the x. So I have to, the inverse operation of square rooting is to square. So square both sides. The square root and the square cancel, leaving me x is equal to 4 squared is 16. Almost done, guys. We're not going to work this whole note, so don't freak out on me. We just got to work 3 more problems, then we're done. Okay, 3 more easy problems, then we're done. So we're not doing this whole notes. All right, number 30. A raised to the 3/2 power is equal to 8. Okay, A raised to the 3/2 power is equal to 8. So again, change this to exponential form. Okay, or excuse me, radical form. So go ahead and drop down 8. We can say radical, put your index in, put your base in, put your numerator in. Okay? Now, this is cube. In order to get this off of that A, I'm going to have to cube root. So I do the inverse, and what I do to one side, I have to do to the other. So the cube root and the cube cancel, leaving me the square root of A is equal to 2, because 2 times 2 times 2 is 8, which is the cube root of A. From there, I square both sides. Square root and square cancel. A is equal to 4. All right, give me thumbs up on that. Give me thumbs up real quick on that you're good 27 through 30. Okay, you're good 27 through 30. Give me some thumbs up in the chat box. Hey, feeling pretty good with that. Pretty simple. Just got to change the form of it and then solve from there using rules. All right. Looks like we are all good. Or maybe not. Oh, yeah, we're good. Most of us are good. Sorry. All right. So looking from there, okay, going up here, our last two. Over here, our last two. So we're not going to do anything on your homework too. Hey, listen to this on your homework. Stop at 32 on the homework. So this, we're not doing any of that. Don't stop at 32 on your homework, okay? So I'll tell you this, on lesson 5.1 homework, stop at 32. All right, let's finish this up here. So 31. Again, first step, guys, put it in radical form. So do what we've been doing. Draw a radical sign, get our symbol in there, take the whole base in there, and then put that 2 on the outside, and that's equal to 25. So again, didn't change anything about the problem, just changed the way it looks. Okay. From there, I can square root both sides. Because that's to the square. Square root and the square cancel, leaving me the cube root of 125x is equal to 5, right? Square root of 25 is 5. Then from there, I need to get that 125x alone. So I cube the cube root and the cube cancel, leaving me with 125x is equal to 125. I then just isolate x by dividing by 125. And 125 divided by 125 is equal to 1. As long as you know how to change the form and you know the inverse of squaring and square root, cube and cube root, whatever it is that you're doing, okay? Whatever it is that you're doing, just simply change the form and then you're good, guys. All right, number 32, last one of the day. Be happy. So, change your form. 216 is equal to, again, let's do our radical sign, drop our base, bring our index in, and then put the cube on the outside. Okay, from there, we're going to cube root both sides. Cube root both sides. Cancels, cancels. The cube root of 216 is 6. 6 times 6 times 6 is that. And then that's equal to the square root of 4p. Square both sides there. That's 36 is equal to 4p because the square root and the square cancel there. Divide both sides by 4 and get p is equal to 9. And that would be my final answer there. You can plug that in there. 4 times 9 is 36. And basically, it's the square root of 36 cubed is 216. So it's another easy way you could check it. Guys, that is all I have for you today. Okay? That's all I have for you today. Give me a thumbs up saying that you're good with this. Give me a thumbs up saying, hey, I'm good. It's all gravy. It's all good. It's all good in the hood. Seeing those come in. Good, guys. Good, 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 good. Hey, just a reminder, okay? Just a reminder. Couple things. Couple things before I just let you go for good, okay? Couple things. This is our schedule, okay? So this was today. We did 5.1 notes. We started at 12:30. We've gone an hour and a half, but we kind of started late, so not really truly an hour and a half. All right. So this week, you need to make sure you turn all chapter, I said chapter 5, I meant chapter 4, guys, sorry. Make sure you turn in all chapter 4 work in by 4 o'clock via option 1 or option 2. Option 1 is this right here. Turn it into the school, picking up a new packet. Option 1 would just simply be emailing me a PDF copy of it. I was going to make an assignment for it where you could like attach it to an assignment, but just make it a PDF, email it to me if you can't get out and go get that. If you do get out and do it, be safe, be precautious, get in there and come right back out. I haven't heard any complaints, and I know several of you have dropped it off, so I appreciate that, okay? That's all I have for you, and then our schedule next week. So Friday, make sure you turn that in. We did that one, so I'll see you Monday at 12:30. We'll review lesson 5.1. I'll answer any questions you have, and we'll complete 5.2 notes at 12:30 then, okay? If you have any questions, feel free to email me, guys. If not, thanks so much, guys, and I hope you guys have a good day. You'll feel free to log off. Or if you have any questions, feel free to stick around, and you can hit me up. Yeah, no problem, Jake. Yeah, thanks, Andrew. No problem, man.